Okay, so I'm going to start working through some problems from chapter 3.8 on the homework set. Chapter 3.8. Okay, so let me bring up the first question that we have to do, question number 7, and we'll take a look at what question number 7 says. So 3.8, question number 7 says, you're given the length density function delta L of x of an idealized one-dimensional object along the x-axis. This is like our wire, okay? For each problem, calculate the x component of the moment and the x coordinate of the center of mass. Okay, so we're given for this our length density function. It's going to be 3x squared plus 2x plus 4 plus 4. And x is an element of 2 to 7. Okay, so that basically means we've got this length, and we're going to go from 2 to 7. Okay. So this is, this really thin object that we're trying to do. Okay, so then we're looking for center of mass. So part A says, right, we want the x component of the moment. That's what the question was asking for us. And the x component of the moment is defined as being integrating from A to B, x times the length density times dx. So let's remember our moment, right? Our moment of mass says what's our position and what's the density at that particular position, right? And then so this right here is basically looking at like our mass, right? Because it says what's our density, times this tiny little thickness. And this says where are we along that x line, right? This is a wire that we're strapping across the x-axis, okay? So the first thing I want to be able to think about is what's the total mass of our wire. Right? We said dm is equal to delta length density times dx, and I integrate both of these. I'm going to go from A to B. Okay, so then our center of mass, this is kind of like a review. This is our x bar. It's going to equal to, right, I'm going to go from A to B, our x, our delta length density times dx, all over the total mass, A to B, delta length x dx. Now be very careful. You're going to be tempted to cancel these out because it looks like the same thing. But remember, with integration, I'm multiplying by x here. So what I have to do is I have to integrate this whole function, get some value. Integrate this whole function, get some value, and then divide them through. I absolutely cannot cancel these two out. Okay, so be very careful. So this is mx all over m, right? This is our, mass times our x center, basically our x component, and this is divided by the mass. Okay, so when I go to work it through, I'm going to look at x is equal to, this part here is going to help me in my part B. I'm going to go from 2 to 7. They gave me that at the very beginning, right? X times my delta length density, 3x squared, plus 2x plus 4 dx. This is our power rule, right? So we're just going to be integrating from 2 to 7, 3x cubed plus 2x squared plus 4x dx. Okay, so the power rule attached to all of these here. So 3/4 x to the 4th plus 2/3 x to the cube plus 2x squared, and I'm going to evaluate that from 2 to 7. Okay, so I plug in everywhere I see an x, I plug in the 7, I get a number, and I subtract out everywhere I see an x, I plug in a 2. I subtract out, and I'm going to get 2102.08. Okay, so this gives us our x component of the moment. Okay. Part B says, right, I want the x coordinate of the center of mass. Okay, so remember our x coordinate, right? I need to be able to figure out what's our total mass, right? Because I'm going to divide that into m times x. So this is my m times x right here. I need to divide out what my mass is. Okay, so let's calculate out our total mass. That's m. We're going to go from 2 to 7, and we're going to integrate our delta length density times that tiny little sliver of thickness, dx. This is 3x squared plus 2x plus 4 dx. I'm just doing power rule on all of these here. So I'm going to get my total mass is going to equal to x cubed, right? So 3x cubed divided by 3 gives me x cubed plus x squared plus 4x integrated, evaluated from 2 to 7. Okay, so I plug in everywhere I see an x, I plug in a 7. Subtract out everywhere I see an x, I plug in a 2. And I'm going to get my total mass is equal to 400. That's from 2 to 7, the mass of the wire. From 2 to 7, the mass of the wire is equal to 400. I forget what the units are in this particular problem. So now to get this x coordinate of the center of mass, right, I get the x component of our moment, and I divide it by the total mass. So I'm going to get what I got in the first part, 2102.08, divided by 400, that's my mass. 5.25. Okay. So be very, very careful. You want to be super careful on this spot right here. Do not delete these out. Do not cancel these out. You must integrate it, right? Because x times this value is going to give you this value here, right? And then if I integrate this delta length density function from A to B, right, it's going to give me the mass. And I need to integrate everything first and then divide it out at the end. So that's question 7. Question 8. Question 8 from chapter 2. Let's read it first. So question 8 says, we're going to do the same thing, and we're given our delta length density function is the cosine of x. Okay, so it's, right, our density is changing sinusoidally, cosinusoidally, and our x is an element of minus pi over 4 to pi over 4. Okay, so this basically tells us, you know, if we're going along this x bar, right, my position goes from minus pi over 4 to positive pi over 4. Okay, so those gives you the bounds of integration. Okay. So let's remember our total mass, right? M is going to equal to, we're going to go from A to B, just our length density function times dx. And then our x component is going to equal to A to B x times our delta length density function dx, right? So our mass times our position integrated from A to B is going to give us, right, our x component of our moment. And now if I want this x coordinate, I'm going to divide these two terms one by each other. Okay, so the part A says, let's calculate out the first one. And x, I'm going to go from minus pi over 4. This is what they gave me, to pi over 4 x times cosine of x dx. Okay. So in this case, we're doing integration by parts. Okay, so my u is equal to x. My du is equal to 1 times dx. My dv is equal to the cosine of x dx. Remember, I have to integrate this in order to get v. And get my v is equal to the sine of x. And remember, integration by parts is uv minus the integral of v du. Okay. So when I go to set this up right over here, what I'm going to get is u times v. So my u is x times v. This is sine of x minus the integral of v, sine of x, oops, times du, which is dx. Okay. So when I go to integrate this out, basically I'm looking at x sine of x, right? This is going to give me a minus cosine, but this is minus times minus, this becomes plus cosine of x, and I'm going to go from minus pi over 4 to pi over 4. Okay, so when I plug in everything, right, so you get pi over 4 sine of pi over 4 plus cosine pi over 4 minus, let's do the minus part, minus pi over 4 sine of minus pi over 4 plus cosine of minus pi over 4. Okay, so when I work everything through, remember your sine and cosine of positive pi over 4 is radical 2 over 2. Okay, here it's going to be negative radical 2 over 2. So when I go to add everything together, basically I'm looking at, I get 2, sorry, radical 2 times pi over 8 minus radical 2 times pi over 8. Okay, so when I get this together, how did I get the pi? Oh yeah, sorry. This is pi over 4, sorry. This is going to give me my mx. Subtracting these things out gives me 0. Okay, that's interesting. Now let's take a look at part B. I almost don't even need to do this because when I go to calculate this out, remember my x component is mx divided by mass, but let's go ahead and calculate out our mass, and then we'll just multiply everything through. Okay, so this part I have to calculate our mass. We're going to go minus 5/4, 5/4. And now in this case, I'm just integrating my length density. So I don't have to worry about integration by parts on this one. This is just going to be cosine of x dx, which is equal to, when I integrate, I get sine of x, and I'm going to integrate from minus 5/4 to 5/4. So the sine 5/4 minus the sine of minus 5/4 is going to give me, this is radical 2/2 minus a minus radical 2/2, which is just going to give me radical 2. So my mass is radical 2, okay, and I'm going to divide this through. So my x bar is equal to mx divided by the mass, which is 0 over radical 2, which is equal to 0. Okay. And that is question chapter 3.8, question 8.